We're the Stats Medic lesson notes. So 1.3b, where do I stand? So how did Mr. D's height compare with other AP Stats students? In order to answer this question, 21 students were sampled from Focus. Their heights in inches were, and it lists the data. Below is a dot plot of the distribution of the data. Add in a critical feature of the dot plot that would cost you a point. The x-axis is not labeled, so make sure you add that in. So we are going to use Desmos on this. So I'm going to go over to Desmos, and my data has already been put in. So you'll put that data in. We want to create a dot plot. So we are going to type in dot plot. And then hit the little magnifying glass. Well, let me slide this over. There we go. Now hit the magnifying glass. There we go. So if our data is just whole numbers, then our bin width would be 1. If our data was in the tenths place or anything like that, and you want every dot to represent a location, then you would change that to 0.1 or 0.01, whatever it is. You've got to change your decimal for the bin width. So these just all go on top of itself, wherever they're located. You can click a dot and see what it represents. So let's look at our dot plot. Do you see the mistakes? There are 2. What is one of the mistakes?
There should be 562.
Yeah, so we're missing a dot here.
There should be one on 77.
And not 76, so let's mark that out. Okay. All right, median height. How do we find the median height?
Cross them out.
Yeah, cross them out, left and right. You're finding the middle. So you can go through and do this. How can we use Desmos to find it? Yeah, we can type in median. So if we want, oh, I don't want uppercase though, I want lowercase. There we go, 63 is the median. So 63 inches. So describe how you found it. So we know it's in the middle. You mark them out on both sides. We can also do median in Desmos. Or list in order least to greatest. And find the middle. Okay, we need Q1 and Q3. What does Q1 represent? First quarter. And then what does Q3 represent? The third quarter, yeah. So we need to find Q1 and Q3. So do y'all remember how to find it in Desmos? Yeah. So if I just type in, so I'm going to mark that median out, and I'm just going to put in, oh, why is it always uppercase when it begins? Is it stat or stats? Stats, yeah. It's got to go to plain text instead of italic. So that's in. And then it gives us all the 5-number summary. So Q1 is 61.5, Q3 is 66.5. And then describe how you found them. So we're going to write Desmos stat in. So Q1 is the first 25%, 25th percentile. So it's the bottom half of the half. And then Q3 is the top half of a half, which is the 75th percentile. So they're broken up into quarters. That's why they're called quartiles. So upper 25th percentile would work too. Record the following values and use them to make a box plot. So go back to your Desmos, look at all of the values, minimum, Q1, median, Q3, and max, and we're going to fill in those values. And let's make our box plot. So we start with a dot at the minimum. They don't even have 57 listed here. So we need to go ahead and put that on our number line since it was left off. And we need to title this. Or label it, I should say. So put a dot at the 57. So we want to go above the x-axis, so that's why I put the dot up. And then we'll put lines at Q1, median, and Q3. And that makes our box of the box plot. And then put your max dot and connect them with, back in 8th grade, we called this a box and whisker plot. Okay, let's have Desmos make this box plot for us. I'm going to turn the dot plot off just by clicking the color. I'm going to go here and write or type box plot of N. You can zoom in and out. Okay, why does our box plot look different? What did Desmos do for us? Yeah, it excluded the outlier. It said this dot right here is an outlier. We can click that off and then give us the whole box plot. We can make the offset. So let's say I want to compare two box plots. I can offset it by 4 and that moves it up. I can change the height. Let's say I want to be able to see that box a little bit better. I'm going to put it as 2. Just some options. So let's turn that exclude outliers off. So let's talk about the IQR. Where is the IQR on a box plot found? It's in the box, exactly. So let's go ahead and find out what the IQR is. We do Q3 minus Q1. So 66.5 minus 61.5. And it's 5. So 5 is our IQR. The middle 50%. And where you find it, IQR is the box. So far we've just been saying there's a possible outlier at this number. Well, now we know how to find if it's truly an outlier. An outlier is found anything outside of this Q1 minus 1.5 times the IQR, or Q3 plus 1.5 times the IQR. And that kind of creates a boundary. So we're going to put these boundaries on our box plot so we can see where the outliers are. So way too small is anything that is less than 61.5 minus 1.5 times 5. And Desmos is a calculator also. So we can just put this in here. 61.5 minus 1.5 times 5. So it's 54. So anything lower than 54 is considered an outlier. Look back at our data. Do we have anything lower than 54? No, 57 is our lowest. So we're going to put no low outliers. But you can still have a high outlier. So we would do 66.5 because we take Q3 plus 1.5 times 5 to find out what that is. So that's 74. And look back at your data. Do we have a high outlier?
Yes.
Yeah, it's at 77. So high outlier at 77. Okay, so what if we had just a lot of data to look at and to look through? We want to be able to put this on Desmos and then transfer it to our paper. So instead of it just being this 61.5 minus 1.5 times 5, we're going to put x equals. And that's going to create a line, a vertical line for us so that we can see the boundaries for those outliers. And then do the same thing for the other one. X equals. Bless you. And just because I want to kind of see it in a different way, I'm going to change these to a dotted line and red. So you go up to that gear and then, or the settings button, dotted line and red. And now I can see where the boundaries are. I can see where the outlier is. Now if I click exclude outlier, that makes a whole lot more sense. It shows where exactly that cutoff point is. So if you were asked a question, would 75 be an outlier? You would see it on there. You could add that extra point in, you could see it. So let's add this to our paper right here. So I'm going to put a little star on the 77. I'm going to put a dashed line at where my outlier lines or boundary is. And then the new point, the new maximum is at 72. So I put a point there. And then 54 is low. There is no outlier, so I'm not going to worry about that. My number line doesn't even go to 54. So I just did the right side. Okay, now we got to answer the final question. Suppose Mr. D is 63 inches tall. How does his height compare with the AP students? So I want you to think about that. And we need to answer it in context. So before we do the in context, let's just talk about it. What do you notice about his height compared to what the data we have?
It's at the median.
It's at the median. That's good. Okay, so what does that mean?
He's taller than half and shorter than half of the students.
Exactly. He's taller than half and shorter than half. He is exactly in the middle. So let's write that. We need to do a sentence starter. Mr. D's height of 63 inches. You always want to include the values. So if you just say his height is taller than and shorter than the median, that wouldn't do it. You've got to include numbers. Is the median of the class which means he is taller than half the class or half the students and shorter than half the students. There we go. Okay, let's go to the vocab review. So IQR is found by doing Q3 minus Q1. To determine if it's outlier, you look for low outliers and high outliers. Low outlier would be smaller than Q1 minus 1.5 times the IQR. Then our high outlier would be Q3 plus 1.5 times the IQR. So you got to have your two boundaries on the left and the right, on the low side and the high side. Box plots, we find the 5-number summary by doing in Desmos. We just do stats of our lists that we made. You can also do it in the calculator, 1var stats. So we get our 5-number summary. We use that to create our box plot. Each section holds 25% of the data. So they're broken up into quarters. That's why we use quartiles. IQR is the middle 50, which is inside the box. Okay, and then when we compare distributions, we've got to use SOCS. So for box plots, symmetric is going to look the same on both sides of the median. So it'll look like similar to that. So that would be symmetric. When it's about the same. And then we have right skew would look like this, or skewed right. And then left skew would be the other way. If they're about the same on both sides of the median, then that would be considered symmetric. If you can see a long tail, then it's going to be skewed. Okay, the outlier, you would find that by doing that 1.5 IQR rule, where you go above it and below it. You find the median for the center, median if it's skewed, and then mean if it's symmetric, which if it's symmetric, then our median and mean should be about the same. Oh, I should put symmetric. Spread is also called variability, and we find that by doing the IQR here. If we had actual data, we'd find the standard deviation. So for us today, we're going to use IQR for spread. And then you always want to use context. And then comparative language would be greater than, less than, about the same, or same as. So make sure you use verbs or numbers, words like that. Yeah, I can't even talk. Okay, so what I want y'all to do is do the application problem. Go ahead and look at that, compare the two, and we'll talk about it when you get done. Okay, hopefully that gave you enough time to answer. I found the IQR, the approximate IQR. So let's look. Shape. So shape for University of Michigan is approximately symmetric. For Michigan State, it is skew right, or right skew. So outliers, were there any outliers? No, because we found IQR, you could do times 1.5 and go above and below. Center was our median, which was at about 25. Okay, spread was IQR. Okay, so as long as you got each one of those things, write it in sentence form and use context. So this is what I wrote. Yours may be written a little different, and that's okay. The distribution of points scored by the football team of U of M is approximately symmetric, while Michigan State's points scored is slightly skewed right. You can write it in any way you want as long as you include context and then you answer the symmetric skewed right. You do that. The center of both teams appear at the medium, which is 25 points. So that's your center. It appears that Michigan State has more variability with an IQR of 21 points, of about 21 points, compared to U of M with an IQR of about 8 points. So you can say what the IQR is, but also include, well, what does that mean? The bigger the IQR, the bigger variability, the bigger the spread. So if you use the word spread, that's fine too. They're more spread out compared to the other one. And then the last sentence says, neither U of M nor Michigan State appear to have any outliers.